The first time you cross a serious mountain range, you feel it in small details before you ever see the big wall of rock. The air dries out or turns suddenly wet. A warm wind becomes a cold blade. Clouds stack up on one side and disappear on the other, as if someone drew a boundary in the sky. Roads begin to bend and climb, towns get rarer, and then you notice the strange part. Whole countries start behaving like they were designed around that ridge line. Farms cluster where meltwater can reach them. Big cities sit at the mouths of valleys like gatekeepers. Borders trace high crests that most people will never step on. Mountains do not just sit there looking dramatic. They decide where rain falls, where rivers run, where armies can move, where trade is cheap or expensive, and where millions of people end up living. If you want to understand why a country's weather, roads, and even politics look the way they do, you often start with the high ground. Take the Himalayas, the most extreme example of a mountain system that dictates the rules for everything around it. This arc of peaks stretches roughly 2,400 kilometers from Pakistan and India through Nepal and Bhutan into Tibet. Along that spine sit 14 mountains over 8,000 meters, including Everest at 8,848.86 meters. Those numbers matter because at that height, the range behaves like a continental scale dam for air. Moisture-loaded winds from the Indian Ocean slam into the southern slopes, rise fast, cool, and drop huge amounts of rain and snow. That uplift helps power the South Asian monsoon system that so many countries depend on for agriculture and water. Then the air crosses the crest line and descends into Tibet and Central Asia, much drier than it arrived. That is a rain shadow big enough to influence deserts, grasslands, and entire patterns of settlement. Look at a map of northern India, and you can see a second kind of control, the way mountains determine where people can even build a functioning country. The Himalayas feed some of the world's most important rivers, including the Indus, the Ganges, and the Brahmaputra system, through snow and glacier melt as well as seasonal monsoon precipitation. Those rivers create plains that can support dense populations, but the same mountains that supply the water also channel it into flood risk. When the monsoon is intense, runoff from steep catchments arrives quickly. That is why the Himalayan foothills and river plains live with a constant trade-off. Fertile soil and water on one hand, landslides and floods on the other. The range also draws hard lines for transportation. If you want to drive from the Indian plains into the Tibetan plateau, you do not get to choose a straight route. You go where passes exist, and passes in the Himalayas are limited, high, and seasonally hostile. Some of the most famous routes are above 5,000 meters, where engines lose power and people lose oxygen. That is why a handful of corridors and tunnels become national-level assets, not just engineering projects. It is also why many Himalayan borders follow high ridgelines. In mountain geography, the watershed divide is a natural border because it is easy to define and hard to cross. The result is a region where weather, water, and borders all rhyme with one another because the same crest that splits rivers also splits armies and trade. Move to South America and you meet the Andes, a mountain chain so long it basically becomes the backbone of multiple nations at once. The Andes run roughly 7,000 kilometers along the western edge of the continent, and in places they widen into high plateaus where major cities sit at elevations that would feel surreal to most Americans. La Paz is around 3,600 meters above sea level, and Quito is about 2,850 meters. Those are not just trivia points. They tell you how the Andes have forced human settlement to adapt to thin air, strong sun, and steep terrain, and how the mountains create vertical zones where temperature and crops change quickly with altitude. Weather control in the Andes is brutal and precise. Moisture from the Atlantic can travel across the Amazon basin, but when that air finally hits the eastern Andes, it rises and drops rain, feeding cloud forests and headwaters. On the other side, descending air can be dry enough to help sustain the Atacama Desert, one of the driest places on Earth, along parts of Chile and Peru. Add the cold Humboldt Current offshore, which stabilizes the atmosphere and reduces rainfall along the coast, and you get a strip where huge populations live beside desert, relying on rivers that originate high in the mountains. In Peru, coastal cities, including Lima, exist in a landscape that naturally wants to be dry. The Andes are the reason water arrives at all, and the reason it can disappear quickly when climate patterns shift. The Andes also decide borders and national identities in ways that are easy to miss if you only think in straight lines. Chile is narrow and long because the Andes limit expansion eastward, while the Pacific limits it westward. Argentina's populated core sits largely east of the mountains, where land opens into plains and agriculture scales up. Between them, the crest line becomes a logical border, but the practical border is often defined by passes, tunnels, and a handful of trade routes. If you control the passes, you control the price of moving goods across the continent. That is mountain power translated into economics. Europe has its own master switch range, the Alps. They are smaller than the Himalayas or Andes in length, roughly 1,200 kilometers. But the Alps sit in one of the most crowded parts of the world, wedged among major economies. In that setting, a mountain range does not need to be the tallest on Earth to control countries. It only needs to stand in the right place. The Alps split air masses moving between the Mediterranean and northern Europe. Cold, dense air can pool in valleys. Warm, dry, downslope winds can race off the mountains. The most famous example is the Föhn, a wind that can push temperatures upward rapidly on the lee side as air descends and compresses. That matters because it affects snowpack, avalanche risk, and seasonal water availability in the river systems that start in alpine ice and snow. Now follow the rivers. The Alps are a water tower for Europe. The Rhine, Rhone, Po, and Danube are all connected to alpine precipitation and meltwater. Those rivers support shipping, industry, and farmland far from the mountains themselves. Switzerland's location at the heart of that network helps explain why it became so tied to transit and banking, and why its internal geography leans hard on tunnels, passes, and rail. In a country like Switzerland, transportation is not just infrastructure. It is the condition of national cohesion. If winter closes a pass, entire regions feel farther apart in a practical sense. The Alps also shape borders in a very old way. They made some borders stable simply by making conquest expensive. Mountain barriers slow movement, isolate valleys, and create local identities that can last centuries. You can see it in the patchwork of languages and cultural regions in and around the Alps. Even today, the most critical links across the range are engineered choke points. The Gotthard-based tunnel, for example, exists because Europe still needs a dependable way through the high ground. When a mountain range forces you to concentrate movement into a few corridors, those corridors become strategic. North America's classic controlling range is the Rocky Mountains, stretching roughly 4,800 kilometers from British Columbia down into the American Southwest. The Rockies are not just a scenic ridge. They are a continental divide that shapes water, climate, and settlement across the West. On one side, rivers eventually reach the Pacific. On the other, water drains toward the Atlantic or the Gulf of Mexico. That divide matters every time the West argues over water rights, reservoir storage, and drought. The rain shadow effect is one of the Rockies' biggest levers. Moist air from the Pacific rises over the western slopes, cools, and drops precipitation. By the time it descends into the interior, it can be much drier, contributing to the semi-arid basins and plains east of the range. That is part of why the Great Basin and portions of the interior West are dry, and why irrigated agriculture and managed water systems become central political issues. If you live in Denver, Salt Lake City, or Albuquerque, you are living in a region where mountains decide how reliable water is and how expensive it becomes to deliver it. The Rockies also dictate roads in a way Americans understand instinctively. The interstate highways that cross the range do so at specific passes for a reason. Weather at altitude creates closures, chain requirements, and seasonal risk. Freight movement concentrates into a limited number of routes. If a tunnel closes, the detours are not mild inconveniences. They can be hundreds of miles and hours of delay. In mountain countries, the map may look large, but functional distance is measured by past conditions and grades. Cross the Atlantic again and look at North Africa. The Atlas Mountains run for roughly 2,500 kilometers across Morocco, Algeria, and Tunisia, and they function like a climate hinge between the Mediterranean-influenced north and the Sahara to the south. Northern slopes catch more moisture from westerly winds and Mediterranean systems, supporting forests and agriculture. South of the crests, aridity ramps up fast. That gradient shapes where major cities and farms cluster, and it changes what development even means. Morocco's large population centers and agricultural regions concentrate where mountain-fed rivers and rainfall patterns allow it. Meanwhile, routes through the range become economic gates, linking ports and interior cities. Mountains can also create internal division inside a single country, and the Caucasus are a sharp example. This region between the Black Sea and the Caspian includes peaks above 5,000 meters, with Mount Elbrus reaching 5,642 meters. The range forms a serious barrier and a complex corridor zone between Russia to the north and Georgia, Armenia, and Azerbaijan to the south. Here, the mountains influence borders, languages, and security because they segment terrain into valleys and basins that are hard to unify. Narrow passes and tunnels carry outsized importance. When a region's geography forces movement into a few corridors, control of those corridors becomes a national issue, not a local one. Now shift to the Horn of Africa, and you see mountains controlling a country in an entirely different way. The Ethiopian Highlands, often called the roof of Africa, rise broadly above 2,000 meters and include peaks like Ras Dashen, around 4,550 meters. This is not a thin ridge. It is a giant elevated platform carved by deep gorges. That topography is one reason Ethiopia developed historically, with strong highland centers and more isolated lowland peripheries. Roads are expensive to build. Travel times are long. Regions can feel separated even when they are not far in kilometers. Those highlands also act as a massive water source. They feed the Blue Nile, which flows out of Lake Tana and eventually contributes a large share of the Nile's flow downstream. You do not need politics to understand the mechanism. Rain falls on high ground, rivers collect it, and gravity does the rest. But once you recognize that Ethiopia's highlands are upstream, you understand why dams, reservoirs, and seasonal rainfall there can matter to countries far away. A mountain region can control more than its own country. It can influence an entire river basin civilization. Japan gives a different lesson. Mountains controlling where a modern, wealthy nation can physically fit its people. Around 3/4 of Japan is mountainous. The Japanese Alps, a set of ranges running through central Honshu, include peaks just over 3,000 meters, like Mount Kita at 3,193 meters. The result is that flat land is scarce and precious. That scarcity funnels cities onto coastal plains and into a limited number of basins. Tokyo sits on the Kanto Plain. Osaka and Kyoto sit in the Kansai region, where flatlands and river valleys allow large urban footprints. Mountain barriers shape rail lines, highways, and even the pattern of regional economies because certain routes are naturally easier. Weather in Japan is also mountain-shaped. Moist air from the Sea of Japan can rise over ranges and drop heavy snowfall on the northwest side, while the Pacific side can be drier in winter. If you have ever wondered why some Japanese regions are famous for deep snow, while others are not, you are looking at orographic lift and wind direction translated into daily life. It affects everything from building design to agriculture to disaster planning. On the other side of the planet, New Zealand's Southern Alps demonstrate how a single mountain spine can dominate an entire national landscape. The range runs roughly 500 kilometers along the South Island, with Aoraki Mount Cook rising to 3,724 meters. Westerly winds off the Tasman Sea hit the Alps, dump heavy rain on the west coast, and then descend into much drier conditions on the eastern side. That is why the west is lush, and the east includes regions that can feel almost steppe-like by comparison. For a small country, this creates a strong east-west contrast that shapes farming, hydropower, and settlement. Glacier-fed rivers and steep valleys also make the South Island a place where roads follow the few routes the land allows. If you drive across, you feel how passes become the storyline. Back in Europe, the Carpathians show a subtler, but still decisive kind of control. This arc stretches roughly 1,500 kilometers through Central and Eastern Europe, influencing countries like Slovakia, Poland, Ukraine, Romania, and Hungary. The highest peak, Gerlachowski Szczyt in Slovakia, reaches 2,655 meters. The Carpathians are not as tall as the Alps, but they are extensive enough to shape climate patterns, forests, and river systems, and they form a broad barrier that historically affected migration routes, defense lines, and the development of cities and surrounding plains and basins. Romania is a clean example of how a mountain arc can shape national structure. The Carpathians curve through the country, enclosing the Transylvanian Plateau and forcing major transport routes to funnel through specific passes. That influences trade patterns and regional connectivity, even in the age of highways. It also affects weather. Mountain arcs can trap cold air in basins, intensify snowfall in certain corridors, and create microclimates that make one valley ideal for orchards, while a neighboring ridge is better for pasture and timber. The Atlas, the Caucasus, the Carpathians, the Alps, the Rockies, the Andes, the Himalayas, the Ethiopian Highlands, the Japanese Alps, and the Southern Alps all demonstrate the same basic rule with different accents. Mountains are not just obstacles. They are systems, They move air up and over, turning invisible wind into rain, snow, drought, and rivers. They redirect human movement into narrow corridors, which turns a pass into an economic valve. They carve basins and plains that become natural targets for cities, because flat land with water is where populations can scale. And when high ridgelines align with watersheds, they become borders that are easy to describe and hard to ignore. If you want a fast way to test this idea, look at a country's biggest cities and ask one question. Are they sitting on a coast, a river plain, or a mountain edge where routes converge? Most of the time, the answer is yes. That is not coincidence. It is geometry plus gravity plus weather. Mountains even control time in a quiet way. In flat terrain, distance is measured in miles or kilometers. In mountain terrain, distance is measured in hours and seasons. A 60-mile trip can be an all-day event if the road climbs, switches back, and crosses a pass that turns icy in the afternoon. That difference changes how regions trade, how governments deliver services, and how quickly help can arrive in a crisis. A country with controlling mountains is always balancing the same equation, where people want to live versus where the land allows easy connection. The modern world has tunnels, aircraft, satellites, and heavy machinery, so it is tempting to think geography has been defeated. It has not. It has been negotiated with. The Himalayas still steer monsoon rains. The Andes still decide where water appears beside desert. The Alps still concentrate Europe's north-south movement into a handful of engineered corridors. The Rockies still split watersheds and shape drought politics. The Atlas still draws a line between Mediterranean farms and Saharan aridity. The Caucasus still divides movement into strategic routes. The Ethiopian Highlands still sit upstream of a continent-defining river. Japan's mountains still compress cities into tight plains. New Zealand's southern Alps still split lush rainforest from dry grassland. The Carpathians still bend transport and climate across Eastern Europe. Mountains control whole countries because countries are ultimately made of everyday needs: water, food, movement, shelter, and security. High ground rewrites each of those needs, sometimes gently, sometimes violently, but always consistently. The map you live on is not just a background, it is a machine that keeps running, shaping choices whether you notice it or not. Be curious and always seek to learn something new. Subscribe and see for yourself. Thanks for watching.